All right, so here we go. In example number 18, we have a car that's going around a curve. It shows you in the picture that the curve is kind of following the edge of a circle there with a constant radius r. It tells us that that r is 250 meters. And then it gives us the coefficient of static friction between the tires and the road as 0.90. And asks what is the maximum speed at which the driver can take the curve without sliding. Well, as we mentioned in class, one of the first things you want to do when you recognize that even part of this is a circle is we want to recognize what is allowing the car to go in a circle, or what is allowing it to make this constant radius curve. And we talked about in class that in this case, it would be the friction. And so early on, we can say that the friction is equal to the centripetal force. Now, if we look at the other forces on the car, if you think about the other forces, you've got the force of gravity down, and you've got the normal force up of the road pushing up on the car, and the only other force there would be the friction pointing in towards the middle. There is no other force available, and so therefore the centripetal force pointing towards the middle of the circle must be the friction. Now, here it does say the coefficient of static friction. So we're going to go ahead and change our friction term here. Remember, friction is equal to the coefficient of friction times the normal force. All right. And it is static friction. Sometimes students get a little confused because the wheels are moving, but the part of the wheel that is touching the ground is not sliding. It's actually static. The wheel is pushing forward on the ground. And so we end up using static friction here times the normal force, which is going to then be equal to the centripetal force. And remember from class, we said that the centripetal force is mv squared over r. So at this point, we can actually start putting some numbers in, right? We know the coefficient of friction is 0.9. We can look for the normal force. We'll figure that out in a minute here. We don't know the mass, so we'll come back to that. The V is actually what we're looking for, right? What's the speed that the car can take? And then the R would be 250 there. So I need to figure out M, and I need to figure out the normal force. And what some of you are probably recognizing is, well, if we look at the vertical forces over here, the normal force is equal to the force of gravity on the car. So that normal force, I can go ahead and change it to mg, which is then equal to mv squared over 250. And at this point, you recognize that both sides have m, and so we should be able to just start solving here because we have all the numbers. 0.9 times 9.8 equals v squared over 250. So we just take that 0.9 and multiply by the 9.8, multiply by 250, and then square root both sides, and we end up getting that v is equal to about 40. Looks like I've got two significant figures, so I'm going to go 47 meters per second. There we go. We were able to answer the question. Notice that just like most of the questions that we've talked about so far, the first thing that we did was we identified that since it was a circle, we want to know what is the centripetal force, and then we start working from there. All right.